Welcome to Lesson 2 in Section 1, Repeating and Terminating Decimals. When you divide fractions, sometimes you can get a decimal that looks like this. So when you divide 4 by 5, you get 0.8. Or if you were to divide 1 by 3, you get 0.3333 with 3 dots at the end, indicating that these 3's don't stop. They go on and on and on. So what's the difference here? Well, for the decimal on the left, because it stops after the 8, we call that terminating. Whereas the decimal on the right, because all the 3's repeat and continue forever, we call that repeating. So here are some more examples. On the left, we have some terminating decimals. The first decimal stops after the hundredths place. The second decimal stops after the 100,000ths place, whereas the third decimal stops after the tenths place. So no matter where it stops, you can see that each decimal stops at some point. So that's why we call it terminating. Now for the decimals on the right, we can see that some values repeat. So for the first one, we have 53, 53, 53, 53 repeating. For the second one, the 4 repeats. And for the third one, the 721 repeat over and over. So in each of these decimals, they don't end and some of the digits repeat. Sometimes you can have just one number repeating, 2 numbers repeating, or even 3 numbers. Now because repeating numbers go on and they can be quite long, we can use another way to represent these called bar notation. So what we do is draw a bar over the repeating digits. So for the first one, because 53 was repeating, I can write this as 0.53 with the line above both the 5 and the 3 to show that both of those numbers repeat. Now in the second one, because only the 4 was repeating, we would write it like this, 0.04 with the bar over the 4. And for the third one, we would have a bar over the 7, 2, and 1. So it would look like this. So now let's use a calculator to change each of these fractions to decimals and then indicate if they're repeating or terminating. So when I put in 2 divided by 9 on my calculator, I get the screen full of 2's, as much as my calculator can show me. Now it doesn't have the ... at the end, but if your calculator is full of 2's, then it does repeat. Now let's just write this in bar notation. It would be written like this, 0.2 with a bar. So this is in fact repeating. Now 5 divided by 22, I get this on the calculator, 0.2272727, and so on. So it would be represented like this using bar notation, 0.2 and then the bar over the 2 and the 7. So I'll write repeating for this one as well. Now when I do 7 divided by 8 on my calculator, I get 0.875, or 875 thousandths is how we should say it. Now because it stops after the 5, we'll call that terminating. So we don't use bar notation when it's terminating, that's only for repeating. Now I want to talk about exact and approximate values. If I were to divide 1 by 6 on the calculator, I get 0.1 with some 6's but a 7 at the end. So you may not think that this is repeating because of the 7, but the calculator in fact rounded, because after 6 is another 6 which is greater than 5, so it rounded up. But this does in fact repeat. Now whenever this happens and the calculator rounds, we call that an approximate value. Now when you write it in bar notation, 0.16, or you leave it as the fraction form 1/6, we call that exact. Now we round whenever an estimate is appropriate, but in many scientific calculations, for example, you do not want to round a value. If scientists are landing a shuttle on the moon, and they have to calculate speed, distance, account for wind, and so on, then they're going to want to use exact values in their calculations, because if they are off slightly, then this could result in a crash landing. Now, if you want to know how far away your friend's house is, then it's probably okay to round here. So in some cases, we really need to be exact. And in other cases, approximate value is fine. So here's another example. If I divide 1 by 3, I get 0.3 repeating. An approximate value could be 0.3. This is rounded. But the exact value should be written like this using bar notation. So now you can proceed to the next video in this lesson.